As it's one of the killer metrics in the storage world, we'll stick with latency for now. What we're looking at here is a line chart showing the overall response times in milliseconds of a particular volume on our array. This chart is showing 5-minute intervals. So as we can see, approximately 45 minutes into the chart there's a huge spike in the average response time. We go from around 10 milliseconds to an average of over 100 milliseconds, so a tenfold increase in response time. And that's not good. And because this chart's measuring response times on the array and not considering the host or the network elements, we know that for some reason the array starts struggling to respond to I/O at about 45 minutes into the chart. We can see the high latency lasts for around an hour and 15 minutes and then it returns to normal. Now then, this latency spike could be caused by any number of things: cache failure, RAID rebuild, change in I/O workload from the hosts, or maybe even an issue on the replication link if the volume in question is part of a synchronous replication setup. Now let's look at another cut of the same data, this time breaking out read response time, write response time, and combined read-write response time. This chart represents the same volume at the same times, but it allows us to see that read response time increased a lot more than write response time. And having this extra detail can be very helpful in diagnosing the root cause of an issue. Now let's look at the IOPS that the array was doing at the same time that read response latency went through the roof. Now we're looking at the number of IOPS that the array was performing at the same time we experienced the high latency. As we can see, at the same time the latency went through the roof, the number of read IOPS went from under 5,000 to over 20,000, so more than a 5-fold increase there. So by correlating the two, the latency and the IOPS, we can see that the latency was probably caused by a massive increase in the number of read IOPS that the array was having to handle. And interestingly, as the number of read IOPS increased by about 5 times, the average response time increased by about 10 times. So although our array was doing loads of IOPS, the response time was terrible. Now let's look at a screen capture of a real-time cache write pending metric. This chart is showing us a cache-related metric known as cache write pending, and I should point out that this chart is not related to the IOPS and latency charts that we've just been looking at. This screenshot is of a real-time chart with 5-second updates. The blue line in the chart is the high watermark that the system is aiming to stay below. And we can see on this particular system the cache write pending, indicated by the red line, is spiking between 10% and 70%. These spikes to 70% cause the system to go into an emergency destage mode and switch to a write-through mode, both of which severely impact performance. So each time the red line spikes to 70%, all attached systems will suffer a storage performance drop. And there we go, 3 charts showing the kind of performance detail we can get from a storage array. We can also get port stats on the array, front-end, back-end, and replication ports. What we're looking at here is throughput stats for the front-end ports on a storage array. And as we can see, some ports are clearly being pushed harder than others. And the reason that the red, green, pink, and bright blue ports all seem to be doing the same amount of work is because there are several hosts on the SAN that are connected to all 4 of these ports, and the workload is being balanced across them using a round-robin MPIO algorithm. Let's take a look at the back-end ports on the same array. The back-end ports being the SAS or fiber channel ports that connect the array's controllers to the drives on the back end. And finally, let's look at the throughput on the 2 replication ports configured on this array. As we can see, the replication workload is fairly evenly balanced over the 2 replication ports. Now then, with a focus on storage arrays and storage networks, let's look at some of the areas and technologies that influence performance, as well as often contribute to performance-related issues. First up, RAID.